does the integer n have 3 or more different positive prime factors? Okay, in data sufficiency, in order to say that a statement is not sufficient, you need two answers to the question. So you would have to find a number n that answers yes, meaning that it has 3 or more prime factors, and a number n that would answer no, meaning 2 or less prime factors. Okay, so let's go with statement 1. Statement 1 says that 7 times n over 6 is an integer. Okay, now since 7 and 6 do not have any common factors, which means that they cannot be simplified any further, that means that n over 6 must be the integer. Okay, so if n over 6 is an integer, I could say that n could be 6. Okay, and 7 times 6 over 6 is an integer because 6 cancels out with the 6 in the denominator. Now 6 in the question has 2 prime factors, 2 and 3, so it answers no. But since it could be bigger, let's say for example that n could be 30, that would be 2 times 3 times 5, and it would have 3 prime factors, so that would answer yes. So statement 1 is not sufficient. I have 2 answers to the question. I have a no and a yes. Statement 2 says that 3 times n over 10 is an integer. Now the same story goes here because 3 and 10 do not have any common factors, so it cannot be simplified any further, meaning that n over 10 must be the integer. Okay, so if n over 10 is an integer, well, n could be 10, and 10 is 2 times 5, so it has only 2 prime factors. So for the answer, for the question, it would answer no. But since it can be bigger, you know, it could be 30. Okay, that is 2 times 3 times 5, and then it would answer yes. So I have 2 different answers to the question, not sufficient. Okay, both alone are not sufficient. Now I have to see them together. If n is a multiple of 6 and a multiple of 10 at the same time, all I will have to do the least common multiple of 6 and 10, okay, to find out the smallest possible value of n. And the least common multiple of 6 and 10 I would find out by taking the prime factorization. This is 2 times 3 and this is 2 times 5, so I would take all of the primes, 2 times 3 times 5, with the highest exponents. Well, they all have 1, so it's just going to be 1, 1, and 1, and this is 30. Okay, so since the least possible value of n is 30 and it has 3 prime factors, it would answer yes. And all of the other values of n which are higher would also answer yes, because they would at least have 2, 3, and 5. So the answer would be C.